Alright, boys and girls, welcome to our third video lesson in conic sections in Chapter 9, our continuing quest into the discovery of those elusive conic sections. Alright, now we're going to be doing hyperbolae. Okay, if you remember ellipses were the set of all points, the locus of points, such that the sum of the distances to 2 points we call the foci was always constant. In other words, in our ellipse, if I had a point on the ellipse right here in green, this distance plus this distance was always equal to another point on the ellipse, this distance plus this distance, or a third point on the ellipse, this distance plus this distance. The two greens is always equal to the two browns, is always equal to the two purples when we add those two distances up. Okay? A hyperbola, and again, let's just look here. Notice in the equation of an ellipse we had a plus sign in the middle because we're adding the two distances. In a hyperbola now, it's just reverse. As opposed to adding the two distances, we are going to subtract them. And notice in my middle here, I have a minus sign as opposed to a plus sign. But the equation looks very similar, though the shape looks very different from an ellipse. The equation looks very, very similar to the equation of an ellipse. The only thing that changes, as opposed to a plus sign here, we have a minus sign. Okay, this is an example of a vertical hyperbola. We know that because the y term is the positive term and the x term is the negative term. The positive term, if it's a y, is going to be vertical. If the x were the positive term, then it would be horizontal. But again, if I take any point on the ellipse, like let's choose this point right here. There's my point on the hyperbola. I said ellipse, I meant the hyperbola. And if these are my foci, right here and here, this distance and this distance, if I subtract those, I get a positive difference. And that difference is going to equal every other difference of my hyperbola. So if I subtract these two browns, these two differences are equal. The browns and the greens. The purple differences, the positive differences, this difference of the purples is equal to the same number. Okay, so there is the whole idea of your hyperbola. Okay, let me just erase for a minute. Erase. A couple more words you need to know. We do have the vertices of my hyperbola. Okay, those are these points right here. Okay, the line connecting my two vertices through the center point of my hyperbola is called 2a. So each of these little lengths are called a. So from center to vertex is a. That's this a. Okay. And that distance of 2a is called the transverse axis. So that's the transverse axis. That's 2a. And it goes from, as we can see now, from vertex to vertex through our center. We also have something called the conjugate axis. That's going to go through the center too. It's perp to the transverse axis. The converse axis doesn't really go anywhere, but it is important. Okay, but this is assigned the letter B. The letter B, so 2B is the conjugate axis. I'm trying to write that here with my marshmallow. That's the conjugate axis. And also now, very importantly, we're going to have the letter C. The letter C is going to go from the center to the focus. So the focus is going to be somewhere up in this range. So we have the center to the focus. That line, I'll put that in purple. That line right there is called C. It goes from center to focus. And just like in the ellipses, A, B, and C are pythagorically related, but this time C is our biggest piece. So we have A squared plus B squared is equal to C squared. So we can run through all this stuff again one more time here, and in a horizontal hyperbola, okay? And again, the hyperbola is such that all these points, if I take this point right here, I'll just draw in one here, one point right here in green, this distance to this focus minus this distance to this focus is equal to some number. Well, if I take another point on my hyperbola, let's say right here, this distance and this distance, these two purple distances, if I subtract them, I'm going to get the same number as I got when I subtracted my green values. Let's erase for a minute. Erase, 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 erase. Okay, I think I erased as much as I could. And let's just review. Our center of our hyperbola is right here. That's denoted by HK. These lines, I didn't name these before. These, of course, are called asymptotes. We'll talk more about those in class, but these are asymptotes. Okay. The smiley faces are my foci. Those are my foci. The little flowers here, those are my vertices. My vertices. This green line right here is my transverse axis. Okay, it is denoted by the letter A. So A goes from center to vertex. This dotted purple line right here, this is my conjugate axis. My conjugate axis. 2b is the length of my conjugate axis, but my little b goes from center to edge of my conjugate axis. And in brown here, this length right here, from center to focus, is called c. I do know that a squared plus b squared is equal to c squared. Okay, and I know that this is a Zant hyperbola by looking at my equation, because the x term is my positive term and my y term is the negative term, even though now that a is actually, it looks like it's smaller than b. So what's more important here is that this one is positive and this one is negative to know the direction of our hyperbola. Try one. Okay, name the stuff. We got a center at 0, 0. I like that. So H and K are both 0. I have foci at -4, 0. So I have a focus right here at -4, 0. I have a focus right here at 4, 0. So I already know now that my hyperbola is horizontal. My vertices, I'll change colors here. We'll go to brown, is at 2, 0 and -2, 0. So that's here and here. Okay, so now I actually do know a couple of things. A is 2. C is 4. B is a question mark. I need to figure that out in order to figure out the length of my conjugate axis. I do know now that my transverse axis is 2A, so it has a length of 4. And that's this piece right here. Okay, there's my conjugate axis. I'm sorry, my transverse axis. Now I'm going to get rid of that just because we don't need it. Whoop, whoop, whoop. Let's figure out what my b is. I do know that a squared, so 2 squared plus b squared is equal to 4 squared. 2 squared is 4 plus b squared is equal to 4 squared, which is 16. It looks like b squared is equal to 12. So b is equal to root 12, which is 2 root 3. And root 12, of course, is about 3.5. So I know that my conjugate axis is going to go about 3.5 up on each way, so I'll do that in purple. So my conjugate axis is going to go somewhere about there and there, doing my best. My conjugate axis has a length of 2b, so it's going to be 4 root 3. Okay. Now, what's important about the conjugate axis and the transverse axis, I use those to make my asymptotes. So I'm going to make a box right here through both, using the lengths of my conjugate axis and my transverse axis. So my asymptotes are going to go from corner to corner through there like that. And the slopes of the the slopes of the asymptotes are always either a over b or b over a. In this case, it's going to be b over a, because b was my vertical, because that's my conjugate axis, and a was my transverse axis, which was the horizontal. But so my asymptotes, just so we know, our slopes are plus or minus b over a, which is 2 over, whoa, I take that back. B was 2 root 3, so it's 2 root 3 over 2, which equals plus or minus root 3. Okay, but now my parabola, I'll do this in bar round, is going to look something like this. Hug, hug, hug. It's going to hug my asymptotes. Okay, and my equation, and I'll write that down here at the bottom, I'll do that in green, is going to be, I know it's horizontal, so it's x minus h squared, which is x minus 0 squared, so x squared over a squared, well, a in this case was 2, so this is 4, minus y minus k squared, k was 0, so that's just y squared, over b squared, b was 2 root 3, which is root 12. If I square that, I get 12, of course, is equal to 1. So there's my equation of my hyperbola. We have the equation y minus 4 squared over 16 minus x plus 2 squared over 9. So it does look like I do have an h and a k that are not 0, which is fine. It also looks like I have a hyperbola, which is vertical, because the y is the positive term. So I now know how I have a center at neg 2 comma 4. I just got that from looking at my h and k. So I'm going to go up here and put my center in at neg 2 comma 4, which is right there. I'm doing the best I can with my Marshall-Mello. Right there. Okay. A is going to equal 4. I can see that because a squared is 16. B is equal to 3. I can see that because b squared is equal to 9. So now I can just do my Pythagorean theorem. I do know that a squared plus b squared is equal to c squared. So 3 squared plus 4 squared, this looks a lot like a Pythagorean triple. 3 squared plus 4 squared is equal to 5 squared. So therefore c is equal to 5. Which means now my foci are going to be 5 units away. And actually I can fill in a whole bunch of stuff here. My foci are going to be 5 units away from my center point. So they're going to go up 5 to negative 2, 9. Right here. And I think it's going to be negative 2, I'm trying to remember, negative 2, neg 1. Yep, down 5. So there are my foci. So I'm going to just write those in at neg 2, 9. And at neg 2, neg 1. My transverse axis has a total length of 2a, which is going to be 8. My conjugate axis has a total length of 2b, which is going to be 6. So now I know from here I'm going to go up 4. There are my vertices. Down 4. And my conjugate axis goes over 3. So that's going to be here. Here. That's over 3 and over 3. There, I'm putting it in as best I can with my Marshall-Mello. Here's my box. Whoop. So my asymptotes look like this through the corners of my box. So my hyperbola goes up, hug, 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 hug. Okay, so there's my hyperbola, and the slopes of the asymptotes this time are going to be a over b, so that's plus or minus 4/3, because the a was the vertical and the b was the horizontal. All right, that's it. Let's try one more. Okay, let's do one more here. In fact, you're going to do most of it, but I'm just going to get you started. Let's just think about our hyperbola for a minute. Let's start with the center point. Looking right here, we can see that h and k are both 0, right? So our center point, as you know, is going to be right here at 0, 0. That's an easy one, okay? We also know now, let's decide whether our hyperbola is vertical or horizontal, vert or zont, well, it is going to be, we can see it's going to be, it begins with a z, zont, because the x squared is the positive term and the y squared is the negative term. And last little hint I'm going to give you here is we know that a is equal to 7 because a squared is equal to 49. And b is equal to 9 because b squared is equal to 81. Don't forget we use our Pythagorean relationship, a squared plus b squared is equal to c squared to get our c in order to get our foci. Okay, so why don't you guys do this work, stop the tape, fill in your packet, and I will be back in a jiff to give you the answers. Okay, you should have found our center again was at 0, 0. That's this point right here. We should have found that c was root 130 because a squared, which was 49, plus b squared, which was 81. Those two numbers add up to 130, so c is the square root of 130. So our foci are at plus or minus root 130 from the origin. So that's, and 130 is about 11 and a half. So those are out here somewhere. Those are our foci. This length right here, of course, is c, right? This length right here is c. Our a was 7. This is our a right here. So our conjugate axis, our transverse axis is 14. That's this length. Our conjugate axis was 18. That's 2 times 9. That's this length right here. Okay, which means now the slopes of our asymptotes was the b, 9 over 7, the vert over the zont. So our asymptotes, I'll put those in red, are right here, whoop, and here. So our hyperbola, I'll draw that in green, goes through our vertex, hug, 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 and there is our hyperbola. All right, folks, that's it. Have a great day. We'll see you soon.